Hello all. So today we will be discussing about this NS3 program to demonstrate the bus topology. Then we'll be analyzing the performance whereby applying the UDP application as a client server among the two nodes as a client server. So but before we go ahead with this, so I suggest you all to go ahead with this particular video, which is where I have given you how to simulate the point-to-point network by taking the two different nodes and connect them using point-to-point link and making one node as a client and the other node as a server and applying the UDP application. So please kindly go through this because I'll be showing you in today's video as how to change that particular program where this particular point-to-point program so that you can simulate the bus topology. So only before we go ahead with the current experiment, so all of you please kindly go through this particular video where I have given in my channel, which is a simulation of point-to-point network. So that itself I'll be extending and I'll be changing the program code so that we can simulate the bus topology. Now, without the delay, let us get into the problem definition. So here, if you observe here, so we have to simulate the bus topology. So where they have not mentioned how many nodes we need to place in the bus topology, so it is left to us, right? So they have not mentioned how many nodes we need to place. It's okay. So but what kind of protocol we have to apply? So definitely it is a UDP application, right? It is a UDP protocol which we need to apply there. So before I take you to the simulation, so as a kind of 1 minute brief for this bus topology, as you all know that, so in case of bus topology, what happens in the sense all the devices, whatever the devices you would like to connect in a network, all those devices will be connected to the central bus network. You call it as a bus, a central bus, right? So all the individual devices are connected to the central bus. So in this case study, what you can observe, so there is a printer, single printer, which is shared among 5 different workstation and one server. It is here, whereas all those individual nodes are connected through the bus topology. So that's how. So where you are reducing the utilization of the cables for creating the network, right? In this bus topology. But the major thing which you have to observe right here that in case of bus topology, when only where we say that if everybody start communicating with every other nodes, so say for example this node is trying to with this and this is trying with this, so if at all if any kind of a cross connections or multiple communications have to happen over the single bus, so definitely it leads to the collision. I repeat, it leads to the collision, right? Because congestion will occur, so which leads to the collision. So that is where we in this experiment, so you will be knowing how exactly we create the bus topology and also we apply the CSMA to avoid the collision, right? So we provide that. So before we go ahead, so directly I'll take you to the analysis part of this particular problem definition. So my dear, so this is what the analogy which we'll be considering for our case study. You can create bus topology by having any number of nodes. Okay, so today, whatever the experiment which I'll be showing you in this experiment, I'll be showing you very as simple as there are the 4 nodes which are connected as a bus topology, whereas this is one external node which is connected to this node as a by using point-to-point link. Okay, making sense? So in this simulation, if you ask me how many total nodes are there, definitely there are 5 nodes, but frankly speaking, there are only 4 nodes which are connected to the bus topology, whereas this node is connected through the point-to-point. So that is the reason why I asked you to go through the previous video. So where whatever you saw in the previous video, it is only the point-to-point link between the or point-to-point communication between the 2 nodes. So today I'll be taking you people as a kind of extending that point-to-point network towards the bus topology. Making sense? Yeah. Now let me take you directly that how exactly we created these point-to-point link point-to-point nodes. So we considered or we created 2 different nodes by using as usual node container. Yes, we created the 2 nodes by using node container. So node container is a class for which we created the object as a nodes, and by using this create method you created the 2 nodes. Then later similarly we created 3 more nodes. So again by using a node container itself. So only have quoted in the previous video also. Again I repeat, in the NS3 any number of nodes or any kind of nodes you can create in the NS3 for which you'll be using the same class file, which is we call it as node container. Then this is an object nomenclature which you are giving. It is based on your requirement, right? It's freely you can use any kind of name, right? It is an object which you will be creating. So in such case, again, the method which is used to create the nodes, it is dot create. And so once after you make you create two nodes as a point-to-point nodes and another three nodes as a CSMA nodes in this case. So what we'll be doing in the sense, the first node of the point, get one of P2P node is this. So that also will be attaching to the N2 here, which is a part, which should be a part of CSM nodes, because I want it to be like this, right? I want to connect N0 and N1. Further, I want to connect. So this N1, I want to be a part, make it to be a part of the CSMA network itself. Right. So when we'll be creating the point-to-point link, so it is as I have defined in the previous explanation, previous experiment also, you'll have to define the attributes for that particular point-to-point link. Similarly, you have to define the attributes for the CSMA link as well. Okay, for where we'll be using the class file, which is CSMA helper. I repeat. So in the previous step or a previous slide, you saw how to create the two different types of node by using node container. Whereas if you want to, as I want to connect first two nodes by using a point-to-point link, so I'm using point-to-point helper, for which I'm creating the object as point-to-point. Whereas as I want to connect these nodes as a CSMA nodes, so I am using a CSMA helper. Okay, making sense? Then by using that CSMA, I am connecting all those. Okay, so here, as I have quoted in the previous slide also, again, let me repeat. So the intention behind using the CSMA here, however, CSMA stands for Carrier Sense Multiple Access. When multiple nodes are trying to access the same link, which link? It is the bus. When all the multiple nodes are trying to access same link, if all the nodes try to access the same link at the same time, definitely it leads to the congestion. When the congestion occurs, definitely leads to collision, then drop of the packets will happen, right? So I repeat, when there are n number of nodes which are connected with the same bus link, so and if everybody starts communicating with each other at the same time, it may lead to the congestion. How to avoid that? In a sense, for that itself, we are utilizing the CSMA here. So, okay, in bus for the bus topology, we are applying the CSMA. What is the CSMA? Carrier Sense Multiple Access. However, the name itself says that before any node can access this carrier, what is this carrier? It's the bus link. Before any node can access this link, it has to sense. That is what S stands for. Carrier Sense Multiple Access. It is as same as in a classroom. In a classroom, if before you speak, make sure that nobody else is speaking. Because if somebody is already, if they are already speaking, even if you start speaking, definitely it will become a kind of disturbance, which is a congestion. So before you start speaking, before you start accessing the carrier, make sure that nobody is accessing. That is what CSMA, Carrier Sense Multiple Access. So to reduce the or to avoid the congestion which can happen in the bus, because as n number of devices are sharing the same bus, so there is a possibility of congestion on the bus topology. So to avoid that, we'll be utilizing a CSMA. What it will happen in the sense, it is going to make sure that so only one communication will happen at a time. So every node or any node before it can attempt for communication, it is going to sense the channel, or you call it as check the channel, verify the channel, whether the channel is already utilized by anybody else or not. If they are already utilizing, you wait. If nobody is utilizing, then you start using. It is something like that. So what is going to happen in the sense, as soon as example, if node 0 is trying to have a communication with the node 3, in the sense about their communication, it will be notified to other nodes also. Example, if node 0 is trying to have a communication with the node 3, means in this case, it will be notified to the node 2, node 4 also, so that they will also get to know, okay, they are speaking, so I have to keep quiet. I should not speak. It will be as simple as that. Making sense? So that's how to reduce the congestion in the bus topology, we are using CSMA. So before it can start accessing, it will sense the channel. If nobody else is using, then only it will start using that channel, or recorded as carrier, or it is bus channel. Fine. So that's how. Next, going further. So once after you are connected the nodes, these two nodes as a point to point, again these nodes as a CSMA. So that definitely we need to install the internet stack. So internet stack on every node. So in which are all the nodes will be installing? Definitely will be installing the stack on the N0 of P2P and all the nodes of CSMA. all the nodes of CSMA and N out of P2P. In all the nodes, we will be installing the internet stack. So about the internet stack, we already discussed in the previous example. So then later we'll be assigning the addresses. I repeat, we will be assigning the addresses to the devices in this network. If you see clearly, there are two different types of networks here. This is what CSMA network. You can say this is what a point-to-point network, is it not? So for this, we are, as an example, we are taking the base address for the point-to-point devices. We are using 10.1.1.0, whereas base address for the CSMA we are using it as 10.1.1.2.0. So we will start assigning based on the base address 10.1.1.0 to the P2P interface. Okay, for the P2P devices, we will start assigning from the base address 10.1.1.0. I hope I mentioned this about this in the previous example also. The base address is the initial address. So that base address will never be allocated to any device. Okay, that base address will never be allocated to any device. In this case, so here we are using the base address as 10.1.1.0 for the point-to-point, 10.1.1.2.0 for the CSMA. It is not compulsory to use like this itself. You can use anything. Example, instead of 10.1.1.0, you can say 160, 140, 130.0. Here also you can use anything. But whenever you will be using these IP base address, the mask should be relative. Example, 10 if I instead of 10.1.1.0, if I use 10.1.0.0, in such case, if you should have your mask value should also be 255 255.0.0. It should never be 255. Making sense? So what I'm saying in the sense, whatever may be the base address you specify, the mask should be relative to that mask. Mask address should be relative to the base address. Then second point you should understand, whatever the base address you specify will never be assigned to the any device. So IP addressing will start for the first device onwards from the next IP address onwards. So in that concern, so as here the base address it was given as 10.1.1.0. So what would be the IP address for this? It would be 10.1.1.1. Similarly, the base address for the CSMA is used as 10.1.2.0. So what would be the address for this? It would be 10.1.1.1.2.1, 1.2.1.2.1. This will be 1.2.3. This will be 1.2.4. It will be like this. Making sense? So the IP address are assigned so as a part of interface. So as I mentioned in the previous example also, I have mentioned the stage by stage. First we'll be defining the number of nodes, then we'll be connecting by using any one of the mechanism, then we are providing the interface, right? We created the in total we created 5 devices in this example. One is considered to be a point-to-point, the other 4 we consider to be a CSMA. Then we connected by using point-to-point link, and this is what CSMA link. Then we provided the interface. So as soon as we are considering it to be a 2 different networks, so we are given 2 different base addresses in the previous exam. Here we are given 2 different base addresses. Based on that, so IP addressing has been happened in this particular slide, how you can see here. Fine. Once after the IP addressing is done, then later among all these nodes, one node I have to consider it as a client node. Another node I have to consider as a server. And what protocol I have to apply based on the problem definition of this experiment, you need to apply the UDP protocol. So in that connection itself, you can observe here, I'm going to install the client in the you can observe P2P of get 0 means this is the P2P of get 0. Whereas echo server server I'll be installing on CSMA of get 2, which is get to CSMA 2 in the sense this is what 0, 1 and 2. So in this example, this is what a server. Okay, this is client. If you change, definitely you can change. There's no constraint that you have to make this as a client. You can apply anything as a client. Similarly, you can make any node as a server. In these lines, what I'm showing you that this is made as a client, this is made as server. If you want make this as a client, definitely instead of P2P nodes, you make it as CSMA nodes of get 0. Okay, at that time this will become client. Okay, if you want if you want to make this as a server, in such case CSMA nodes of get 3. Like that, you can make any node as a client and any node as a server among all this set of nodes. Fine. So however, you know this, I have given the previous video also. So inside this Scratch only, we'll be creating the source program and we'll be running the program from this NS3. And if at all, if you want to see the animation, I need to go to the netanim folder. Making sense, right? So I'll take you to the program. So before I take you to the program, however, I mentioned here. So like this, whatever you have learned in the previous video, as I have shown here. So point to point. Okay, this for this point to point program, in that the same point to point program itself, how we can make it to be you know what, bus topology, how we can implement and simulate bus topology. I'll be showing you right now. Making sense? So I'll take it to the NS3. So yeah, I'll take it to the program. So let me open that. So NS the all-in-one 3.3. So inside that NS 3.3, inside that Scratch. So you can observe this is the program, which is a point-to-point program. I repeat, this is the point-to-point program, which was explained in the previous video. You can go through that. This is the point-to-point program. If you want me to show you for the diagram, this is the point to point for the two nodes we have considered, and it was explained in the previous video. You can go through once again. Okay, so this is the point to point program. Now inside this program, what are all the changes to be made? I will show you right now. Making sense? So I'll show you what are all the changes to be made so that it can become what I can say, where a combination of, you can see here, a combination of both point to point and also CSMA. Making sense? Now, anyhow, you have UDP echo client and UDP echo server log files have been created. So let it be. Don't disturb this. Now let me directly take you to the here at this part. So what is happening if you observe clearly? So what is happening if you observe clearly? See, I have to create two nodes as point to point nodes, and I have to create three nodes as CSMA. Then I have to make this also to be part of CSMA. I repeat, here I need to, you have to consider three cases. One case is that I need to create two nodes as point to point, three nodes as CSMA, then make this node also to be part of CSMA family. Making sense? Now I'll show you. Right, for the differentiation. So here, whatever the two nodes I'm creating for your difference, so I'll simply say that point to, what, P2P nodes, right? I'm saying as a P2P nodes. So I'm creating how many nodes? I'm creating two nodes as point to point P2P nodes. Making sense? So I have created two nodes as P2P nodes. Then I'll copy paste this and I'll just, yeah, instead of this P2P, I'll simply say that CSMA. How many nodes I want to create CSMA nodes? Three nodes. Is it not? So here I'll say that CSMA. So I have created two nodes as point to point nodes and three nodes as CSMA. Making sense? So I'm done with creating the three nodes as CSMA nodes. But whenever I'm creating three nodes as CSMA nodes, as I mentioned in the diagram also, I will be creating two nodes as point to point nodes and three nodes as CSMA nodes. Then later I should also make this node, which is N1, to be part of the CSMA family, because this N1 should be connected to both point to point and also CSMA. I repeat, this I should make to be a part of CSMA. While creation, I have created this as a point to point node. Now I need to make this to be a part of the CSMA. How to make it out in the sense? So here, so how to make it in the sense, whatever the CSMA nodes I have created, for that only I have to add. I repeat, I have to add. What I have to add? This among the P2P nodes, whatever I have created in that. So I'll be adding the first node, which is get of 1. So that's how I'm done with creating two nodes of P2P nodes, three nodes of CSMA, and second node of P2P node is attached to the CSMA nodes. Okay, so now, so creation of nodes is done. Next is that, so where I need to make use of point to point link between what? Between these nodes, I have to make use of point to point link, is it not? So I have to make use of point to point link. So it is the same code of the previous program. So let it be. So because I'll be using the same point to point link to connect the node devices. What device, what nodes? It is the P2P nodes. You can observe. So these P2P nodes, whatever I have created, those I am connecting by using a point to point link. So let me make this also as a P2P devices. So making sense? So this also to be a P2P devices because this is the object which I'm creating for the node container. So what I did, I have created the point-to-point link. By using that point-to-point link, I have connected the P2P nodes. Right? I'm done with connecting the two nodes, which is P2P nodes as a. So I have connected by using a point-to-point link. Okay. Next, if once after I am done with connecting them, now I need to go work with the CSMA. So however, point-to-point helper for which I am using here, similarly, I have to use CSMA helper. CSMA helper. I have to use CSMA helper. Let me call it as CSMA. Okay, I have to use CSMA, and then for that CSMA also, I should set the respective. I repeat, I should set the respective attributes like what we say that data rate and what delay, but at that time, so data rate will not be, as CSMA is not restricted to any one device, it is restricted to the channel. So I say it as channel attribute. Both data rate and the delay both are channel attributes to the CSMA, whereas in case of point to point, data rate is the speed where the device is transferring out. So it is a device attribute. So in case of CSMA is not restricted to any device. So it is not device attributes, both are channel attributes only. And when you'll be setting the speed, so can it be directly, for only 5 Mbps left to, it is left to you. If you want to change, you can change. Similarly, delay, is it enough to have, or you would like to have 2 milliseconds, or you want to change, you can change anything. You can change anything. I repeat, you can change anything, but setting the data rate and the delay for the CSMA link is must. Once after the, however, you created the two point-to-point nodes, you created the point-to-point link and connected those two nodes by using a point-to-point link. Similarly, now I need to do whatever the three CSMA nodes you have, though, and the CSM link is created here. Now you need to connect those. So for that itself, again, I'll be using a net device container. So, but here instead of P2P devices, let me say that CSMA devices. Making sense? I'm saying it as CSMA devices, and those CSMA devices I'm installing with the CSMA. Okay, CSMA. For the CSMA nodes, I'm installing the not point to point. This is, see, however, I installed point to point among the P2P nodes. Similarly, how to install this CSMA among the CSMA nodes, right? So now I'm done with creating the nodes, connecting the point-to-point nodes by using point-to-point link, connecting the bus nodes by using a CSMA link. Okay, I'm done with that. So that's what. So if you say, so we are done with the step 2. Now, so next we need to go ahead with the defining the interface. So for defining the interface, definitely I have to initialize with the stack. Okay, as I've explained in the previous video. So here also there is an internet stack helper. You can observe stack is already available in the based on the previous program. So for that I need to install this stack for both the two different types of nodes. What are the two different types of nodes you have? For your information, what are the two different nodes we have? One is the P2P nodes. One is P2P nodes, and one more is, let me copy paste here itself, and one more is what nodes? It is the CSMA nodes. So I have installed stack, which stack? Internet stack helper for both CSMA nodes and also P2P nodes. Once after you're done, see, even if you want to make it customize, basically, if you see this properly, what we did in these lines, even though you created two nodes as a point-to-point nodes, but a second node of point-to-point node, that's what a get of one you already made to be a part of CSMA nodes, right? So it is as same as even though you created two nodes here, so one node you made to be a part of, already you made to be a part of CSMA node. So only left out is only get of 0, which is in the P2P nodes. So what I'll do here, so instead of installing stack for 2 times, if you do like this, what will happen in the sense, this internet stack will be installed 2 times for on this, because one as a part of P2P node and one more as a part of CSMA node. So instead of doing that, what I'll do, so here I will install only on 0th node. So now as a part of P2P node, I'll be installing on 0. Then as a part of CSMA nodes, rest of the nodes I am installing what? Internet stack. Then later, as usual, I need to assign the addresses. Is it not? I need to assign the addresses. So what addresses? So I'll be assigning. So what base address? Wherever I have shown in the diagram also. So first I'll be considering the two different types of addresses. I repeat, I'll be considering two different addresses of or two different types of base address. One is 10110 and one more thing I will consider as 1020. One I will install on the device. What devices? Here we have created two different types of devices for your information. What are those? Yes, yeah. One is the P2P devices. Making sense? One is the P2P devices. One more is where is that? CSMA devices, right? So it's like that. Two devices. So likewise, two on the two different types of devices. One is you can observe for where I have initialized the address. So setting the base as 10110 and that I am installing on the P2P devices. So these when I am installing on the P2P devices, so this also let me call this interface also as a with a different name. Let me call it as P2P interface. Okay, let me call as P2P interfaces where I am installing on the P2P devices. Similarly, so again I have initialized the address. Okay, I don't have to initialize the address again because already here it is initialized, right? So I can directly use set the change the base address. So here whatever the address is set here, that is for the P2P devices, that interface I'm calling as P2P interface. Then I am changing the base address as 1020 and here, so let me call this as what a CSMA interface. CSMA interface where it is been installed or assigned to the okay, these addresses are assigned to the CSMA devices, right? So that's where I'm done with setting the interface. So here we have installed the stack, internet stack, then setting initializing the base address and creating the interface among the P2P devices separately and CSMA devices separately. Now we need to make the respective node as server and respective node as client. So however, based on the previous example program itself, however, we defined the port number as 9 for the server. Let it be as 9 itself. You don't have to change. Okay. Whereas here, very importantly, so when you'll be installing the server, in which node you want to make it to be a server node. This is very important. Which node you want to you want to make it as a server node. As I mentioned, so there are the client nodes. So I mentioned here, right? These are the client server, sorry, CSMA nodes. This is the P2P node. You can make any node to be a part of what or any node as a server node. So if I want to make this node, okay, if I want to make this node as a server, in such case, what family of this this node is belongs to which family? Is it a P2P or CSMA? It is definitely it is a CSMA, right? So and what is the number? As the CSMA started here, it is 0, 1, 2, and 3. So if I want to make this as a server, then I have to use CSMA nodes of 3. So we will do that. So while defining the get, so okay, what kind of node, where exactly I am installing the server, in the sense it is a CSMA nodes. You can also change, my dear, it's not restricted. And here it is 3. So what happens, that last node of the CSMA node has become server. Similarly, I have to install the client also. So here I'm getting the address. Before that, what kind of interfaces here I need? So definitely I'm installing the client for the interfaces. What interface? It is the CSMA interfaces. It is the CSMA interfaces. It is CSMA interface for because your server is connected to the CSMA. So in the server CSMA interfaces, so the third node, whatever the node you defined as a server, to that server I'm creating a client with the same port number. I repeat, here I'm creating a client to the server whatever you have defined. As it is a CSMA nodes, so I'm going to use this CSMA interfaces. So I'm creating the client for this server. And the number of packets is left to you. Again, interval you can change, packet size you can change. And here again defining the client. Again, very important thing. Defining a client. If you want, whenever you want to define the client, as usual. So as you are defining the client here, which node you want to make it to be a client? As same as among these nodes, right now you made this as a server, but which node you want to make it as a client? For making you to feel difference, so we will make this point-to-point node as a client. Okay, So it is a zeroth node of point-to-point nodes. Making sense? This is a zeroth node of point-to-point nodes. So here I'll say that P2P of 0. That's what P2P nodes are, get 0. So that node will start acting as a client. Okay. Then when it has to start, when it has to stop. Similarly, however, it is same as client and the server. So as of for now, I'll just delete these lines because it doesn't require a for the normal simulation. It only requires for the animation. I'll just save it. Let me compile this program and see whether there are any other errors or what kind of output we are going to get. Before that, what is the major difference from the previous program? If you see, so here we had only two nodes. We created three more nodes. Then we had only one type of a link, which is point-to-point link, and by using it was connected. Now we created one more link, which is CSMA link by using CSMA helper, and we connected the CSMA nodes. Then we had only one, stack was installed only in the P2P nodes in the previous example. Here we are also installing in the CSMA nodes. Then we consider only one base address and IP addresses have been assigned in the previous example. So as here, there are two different family of nodes. So we are using two different base addresses. Making sense? So the two different base addresses, and we are installed assigned the respective addresses. Then we made the client and the server is as same as the previous experiment. Only the thing that we are making the server to be a CSMA node and client as a part of P2P nodes. Rest everything is same as your previous program. You can go ahead. Okay, so now let me take you to the terminal. So where, as I hope you know this, right? So where exactly my program, it is in the desktop, NS all-in-one again. Okay, so in that connection, so all this change in the super user, all that I taught in the previous video. So again, if you want me to do it again, I'll show you. As my program is available in the desktop, so inside that it is all-in-one. So I'm changing the super user. Next, I'll be moving to the desktop. Inside the desktop, I'm moving to the NS all-in-one 3.33. Making sense? Let me zoom out so that you can visualize. Right. So now again, inside that, I have to get into the NS33. So this is where I have to provide the command what waf/waf -run scratch followed by the program name. What is the program name? In this case, it is the P2 is the program name. Is it not? P2 is the program name. Right. So I'll execute. You can see if at all there are any errors, it will throw you. If not, it will give you the output. Yeah. Let's wait for the result. It is taking a couple of seconds for compiling and execution. So because it has to link the respective, what. Okay. Sorry. What has happened? The CSMA helper. Okay. Whatever we are using here, right? So the just a minute. CSMA helper will have to include the CSMA module. So we'll have to include hash include. Yeah, this is where you can observe the results. So where you can see the 2 second, 3 second, and 4 second, the client is transferring the data, but you are not getting the complete data, right? So for which let us make use of routing table. So this is where let me use the routing table IPv4 global routing table, global G gaps, global routing helper. So where I will be using the routing table. So we will say that populate routing tables. Fine. So populate routing tables. Now, if you see this, so okay, the respective header file I'll have to include. So which okay, so here the respective header files I'll have to include. So here I'll say that NS3 slash all this must be a lowercase, so don't use in the uppercase, because when you'll be using it as the method, we'll have to use it as a lowercase, uppercase, but at file it's completely the lowercase. Global hyphen, where the R is lowercase, again routing. So again hyphen, H is lowercase, dot H. Fine. So I've used this routing table to record every data. Okay. So let me run this. Yes, quite good. Now you can observe, so at what time the client is sending to the respective destination, which is a server. So which is 10.124. Hope you remember. So 10.124, which is in our case 10.124 is our, this is what our receiver. So again, that is again sending back to 10.111, which is the 10.11 in our case. It is this client, right? Making sense. So that's how the client server is, they are exchanging the data. So then later in this, inside this particular program, you can keep varying the number of packets. Okay, you can vary this time duration. So here we have said, then you can set the nanoseconds, or it can be directly in the milliseconds also you can set. So bandwidth also you can vary. So bandwidth of the point-to-point link and the delay of point-to-point link. Similarly, bandwidth of the CSMA and delay of the CSMA, those parameters you can keep varying, so that you can observe the results. So what is the turnaround time, how much time it do takes. So right now it is taking, you can observe client is getting the response back within a 0.1761 seconds. So if you keep varying the respective delay and the data rate, so and you can observe the results, right? So that is what about the communication. So here if you really see that, so from the previous program, what and all we changed. So it's only the creating extra CSM nodes, extra CSMA link, and by using that connecting, and stack is installed in the CSMA nodes as well. And one more base address for assigning the addresses to the CSMA nodes. That is again followed by the respective client, where exactly you define the server and where exactly you define the client, right? And this is what for tracking all the routing information, we are using the routing helper. So this is for this is what about this bus topology experiment. So if at all, if you want to see that animation, so then use the animation interface. So I'll say that animation interface, right? So where I'll have to create. So because as it is a bus topology, I'll say it as bus.xml. Okay, I'll call it as bus.xml. As I'm having in total, if you see in my our diagram also, in total that we have 5 different nodes. One is P2P node and the another for us CSMA nodes, right? So let me place those 5 nodes. I'll say that set constant position. Okay, set constant position. First node is P2P nodes. P2P nodes, which for in that I'll be using get of 0, right? So for that, what position let me assign 10.0 comma 10.0. Okay, so that's the position which I'm setting for the P2P node. Similarly, how to set for another 4 CSMA nodes, is it not? So this, so CSMA nodes, CSME. So that's how I'll be placing, giving the position for the 4 CSMA nodes. CSME. Okay, one P2P node and another 4 CSMA nodes. So here get of 1 comma 1 2 3. Okay, 0 1 2 3. And the position where you want to keep, you can keep it anywhere you want. I'll make it simple. 30 30 10 10 30 30 40 40 like that. I'm just make it simple. You can place anywhere you want. I'll just place it like this. Okay, likewise 5 for the 5 nodes I have given the position. Let me see the respective pack, header file for this animation interface. Is it we are giving? Yes, netanim module we are using. So now let me run it again. So when I run it again, so I'll have to make sure that the respective XML file is created. Okay, there is one thing, P2P is failed with respect to anim. So yeah, let us see what is the problem. Yeah, here it is, semicolon is the problem. Right, so we are done with the execution. Let me see that XML file whether it is created or not. You can, if you see this, what is the name of the XML file? It is a bus.xml. So let me check it. So you can observe bus.xml. Is it available? Yes, it's available. Bus.xml, it's available. Right now, let me go back. So as I mentioned, for checking the animation, you'll have to go to this netanim folder, right, which is there in this all-in-one. So I have to come out of this 3.33 and get into the netanim. Then only I can run the animation. Is it not? So now, so let me do that. So let me come out of it and let me get into the netanim. So this is where I'll run /netanim. The same thing, whatever I have given in the previous experiment as well. /netanim. So the network animator is open. Now let me open the file, which is the file name XML, right? Bus.xml. Okay, yeah, this is the bus.xml. When I open that, you can observe the 5 nodes. In total, 5 nodes are placed based on our analogy. Also, if you remember, so we made this node as a client and this node as a server. And as one more analogy also, as I mentioned, all these nodes are connected in the form of a bus topology. So whatever this is sending, it will be received to every node, but nobody will respond back. Only the respective server only will respond. It is as same as in a classroom. When I am asking the respective person, so others may hear, but they don't have to ask, answer me back. It's the same as that, right? So let me play. Now you can observe. So 0 is sending to the 4, but it will be delivered to 1, 2, 3, 4. But who is actually responding? It is only the 4. So again, I'm taking an example of your classroom example itself. A teacher is asking a question to the respective student. Whatever the teacher is asking, respective student can hear. At the same time, others can also hear. But who is responding back? It is the respective student only. And whatever he is answering will be heard by others also. So you can observe the acknowledgement will also be heard by all other nodes, but they will be just keeping quiet and listening. It's the same as, right? So that's how the animation of that particular bus topology, where here we are implementing with the bus point-to-point topology just to bring you the connectivity from the previous experiment. So here with the, because as I mentioned earlier also, so already in the previous experiment we saw this, right? So which is point to point. In this experiment we attached the additional nodes to be a part of this, which you are calling it as a bus topology. Making sense? So as I mentioned, so inside in your program, you can keep varying the packet size. You can vary interval. You can say vary number of packets. So even this time duration, everything you can keep varying and check check the results, right? So that's what you can practice. And I hope you understood whatever the experiment I taught till now. Okay, making sense? Thank you. Fine. That's how you can analyze the results in the terminal. So where you are observing that at what time, so which packet has been sent by who to which respective IP address and which port number, right? So in our analogy of client and server. So the same analogy, if you want to analyze in the Wireshark as well. So as I mentioned, so you can analyze the results in the terminal. You can analyze that in the netanim which I shown. So similarly, if you want to analyze the results in the Wireshark. So if you want to observe the results and analyze the results in the Wireshark. So here, however, you have a XML file for the, netanim. For Wireshark, you need to create the PCAP files. I repeat it, you need to create the PCAP files. So when I say that, I'll be enabling the PCAP files. I call it as PCAP all. So for all the connectivity, for all the kind of devices, what kind of devices actually we created? We created 2 different types of links, right? So here one link is a point-to-point link. So for that point-to-point link, I'll be enabling the PCAP file. So only it is point-to-point dot enable PCAP file. So here let me give any name as a P2P. So right here I'm giving the name as a P2P. So similarly, I'll have to create one more PCAP file for CSMA link. So I hope you know that, right? We have created 2 different links here. So one is point to point, another one more link is where is that? Yeah, CSMA. Right, point to point. Similarly, we create one more link as CSME. So likewise, so I'll be creating the 2 different types of PCAP files. One is for P2P and one more is for PCAP. Right. So remember, so we have said 10 seconds. So when the server is starting at 1 second and stopping at 10 seconds. Similarly, client is starting at 2 seconds and stopping at 10 seconds. So based on this time duration only, so we'll have to, these 2 PCAP files will be created. Okay, so now let me run the program again. So once after I run the program again, so based on the names, whatever the names we have given in the program, which is a P2P and the CSMA, those are the PCAP files, right? Name of those PCAP files we have given, right? So those names has to be created once after the execution is complete. So now the execution is complete. I have run it again. So let me give ls. So once I give ls, so search for those names. So here you can observe there is a CSMA. So there is a CSMA one-to-one PCAP file, and there is one more P2P. Search for the P2P PCAP file. Yeah, this is where you can observe P2P. So you can give any other names. You can give any other names. So here you can observe there are a lot of different names, in my terminal. So if you want, you can give anything. I'll say that the P2P example. Anything you can give. Similarly, I'll say CSMA example. So it is only for your information I'm saying that. So name of the PKF files. However, I mentioned the name of the XML file can be anything, but the same file you'll have to open in NetAnimator. Similarly, PKF file name can also be anything. The same thing you will be using. Let me run it again. Okay, let me execute it again. Okay, so once after I'm done, let me list out the files. So when I list out the files, now you can observe. So this is where you can observe CSMA example PK files have been created. Similarly, yeah, P2P example files have been created. Making sense? Now you open the these PK files in the Wireshark. I repeat, you open these PK files in the Wireshark. So how to open? I'll say that Wireshark. Uh, I repeat, write as Wireshark followed by the file name. Whatever the file name you have here, the same file name you give. Okay, I repeat again. What is this? Wireshark followed by that name of the file, which is P2P example hyphen 0 hyphen pcap. Okay, you can also open this 10 also, and you can search in the similar way. I mean, so you can analyze in similar way. I repeat, Wireshark followed by the pcap file name. If you open, so where the results of your simulation you can observe in the Wireshark tool. Making sense? So it is taking quite a couple of seconds to open the Wireshark. So wait for that. So, however, you after only after the XML file. However, only after the XML files like this, bus.xml, the XML files has been created. Then those XML files only you can open and analyze in the NetAnimator. Similarly, only after the PK files have been created, those you can open in the Wireshark. Now you can observe here it is open. So you can observe which is the source node, which is 10.1.1.1, which is a point-to-point node, which is say again 10.1.2.4, which is the CSMA server node. This is the client, this is the server, and which protocol it was applied. It is on the UDP. And what are the respective port numbers? 9 is this port number at the server, whereas 49153, which is the port number at the client. Okay. So that's how you can start analyzing which protocol have been used and what is the packet contents in your data of 1024 bytes, right? So this is where you can analyze this, right? In your program also we have fixed the size of the packet as 1024 bytes. So here also you can see the data size is 1024 bytes, but as you will be attaching the header part also, so the total data which will be transferred, which is the packet length, which is 1054 instead of 1024, because 30 bytes 30 bytes of data which is related to your header part of your packet, right? So this is what the pk file, which pk file, it is the p2p example 00 pk file. Similarly, open other pk files also and start analyzing which at what time, what communication is happening from where to where, what protocol is utilized, what is the length of that, and what is the port numbers, and very importantly, who is the source and destination. Port numbers you can observe here and the respective packet data, right? So that's how you can start analyzing. So which IP version? It is IPv4 version. So the packet is also IPv4 packet. We'll have to start analyzing. That's how. So you can analyze the results in the terminal directly like this. Otherwise, in the NetAnimator. And third way is that analyzing in the Wireshark. Whereas for the Wireshark, you'll have to create the PCAP files. Okay, you'll have to create the PCAP files for the Wireshark. Whereas you'll have to create the XML file for the NetAnimator. Okay. Those are the three ways of analyzing this particular experiment which I shown you till now. Okay, thank you.